Hey everybody, Dr. Nelson here. This is an interactive video lesson about parallel lines. So what's going to happen is you're going to take notes with me for the first couple of pages, and then you have a chance to pause the video and try some problems on your own, and then at the end you can see how you did. Alright, so take a look at this first diagram here, and notice the black line and the blue line, okay, are parallel. Now the $1 million question is why, okay? So if these lines keep on going, they'll never ever touch. And the reason why is parallel lines have the same slope. Okay, so if you write that over here for me. Alright, so the important thing is parallel lines have the same slope. Alright, so let's say for example both of these lines are written in slope-intercept form. So if we know that an equation is written in slope-intercept form, which is y equals mx plus b, all right, both these lines have the same m value. All right, so again, any two lines that are parallel have to have the same slope. So if you turn the page, let's say for example we wanted to write two equations that are parallel to these two equations. So here we have y equals 3x plus 4. So what I'm going to do is I'm going to write it as y equals 3x. Then I can have any other y-intercept. So I'm going to say plus 2. Or I could say it's going to be y equals 3x minus 1. Or I could even say y equals just plain old 3x, because the y-intercept would be at 0, 0, right? Now this one over here, we have negative 5x plus y equals 7. So what I want to do first is I want to first write it in slope-intercept form, which is y equals mx plus b. So in order to do that, I'm going to add 5x to both sides. So now we're going to have the equation written in y equals 5x plus 7. And now that I see the slope is 5, if I want to write another equation that's parallel to this, I would simply just change the y-intercept. So it's going to be y equals 5x, how about plus 2? Or say y equals 5x, say minus 10. Alright, again, as long as it has the same slope, the two lines are going to be parallel. Alright, so now that you understand what makes lines parallel, why don't you pause the video and try the your turn now problems. And when you're done, hit play, and you can see how you did. Alright, good luck. Alright, welcome back. Let's say I do these practice problems. So the question is, which of the following functions are parallel? Circle them. So again, we know that functions are parallel when they have the same slope. So here I know that the slope is 1/3. This one has a slope of 3. This one has a slope of 3. The same as this one. This one has a slope of also 3 because I can now add 3x to both sides. Because now it's going to be written in slope-intercept form, right? So this is really y equals 3x plus 5. And then we have y equals 4x plus 5, so the slope is 4. And finally we have y equals 2x minus 2. So I know that this line and this line, which is actually the same as this one, and also this line, they would all be parallel because they all have a slope of 3. Alright, how'd you do?